In this video, we are going to look at IES Intelligence, a new AI feature in VisualFoundation. Let's get started. IES Intelligence is a new way to interact with VisualFoundation using natural language prompts. In other words, you can type plain English instructions to create, modify, and ask questions about the model. The important thing to know is that VisualFoundation itself has not changed. The same proven analysis engine, design checks, stability checks, and reports are still being used. IES Intelligence simply gives us another way to control the program and understand the model. You can find this tool in the bottom panel next to the Find Tool and Script Command window. For this example, we'll create a footing, apply loads, review the design results, make revisions, and generate a report. First, let's create the footing. We'll do this by typing in, create a 4-foot square footing named F1. Make it 12 inches thick and use a subgrade modulus of 125 pounds per cubic inch. Next, let's add a concrete pier at the center of the footing by typing in, add a 15-inch square concrete pier named C1 at the center of the footing. Make the pier 18 inches tall. Now let's apply the loads to the pier. We'll include dead load, live load, and wind loads in both the positive and negative X directions. Let's type in, apply the following loads to the pier. Dead load of 30 kips downward, live load of 15 kips downward, wind plus X with 6 kips lateral load in the positive X direction, and 25 kip feet moment about Y, and wind minus X with the same magnitude in the opposite direction. Looking at the service cases, we can verify that the loads were created correctly. In the D service case, we see the 30 kip dead load. In the L service case, we see the 15 kip live load. In the W plus X and W minus X service cases, we see the lateral forces and overturning moments applied in opposite directions. At this point, we have created the basic foundation model and applied loads without drawing the footing manually, opening multiple dialogues, or writing any script commands ourselves. Now let's ask IES Intelligence to evaluate the foundation. We'll ask, how does this footing look with respect to stability and bearing? This is where the feature becomes especially useful. IES Intelligence is not just creating model objects. It can also review the design results and explain what is controlling. In this case, the initial footing is too small. Rather than manually changing the geometry and rechecking the results, let's ask IES Intelligence to make a design revision. We'll say, increase the footing size by 1 foot in both directions and let me know if that improves the design. Now it looks like stability is passing but bearing is failing. We can continue iterating and ask IES Intelligence to adjust the model in a more targeted way. If we want to increase the slab in just one direction, we can say, increase the footing width in the X direction in 1 foot increments until bearing passes. IES Intelligence increases the footing size in the X direction. After each size change, it waits for the analysis and design checks to finish, then checks the bearing unity value. The footing size is increased until the bearing check passes. Now we can see that bearing is passing, and IES Intelligence has provided a nice summary of the footing sizes it tried along with the associated bearing unity value. This shows one of the biggest advantages of the natural language workflow. We are still in control of the design decisions, but we can ask VisualFoundation to handle repetitive model changes and design checks much more efficiently. Once stability and bearing are acceptable, let's move on to the concrete design checks. We'll ask, how are the slab shear and flexure checks looking? Since slab shear is failing, let's ask IES Intelligence for a direct design change. Let's say, increase the slab thickness to 16 inches and see if that resolves the slab shear issue. Now we can see that the foundation is passing for shear, but still failing for flexure. IES Intelligence says that the slab shear is now passing and flexure improved, but the unity remains well above 1.0 and that the reinforcement will need to be addressed. We also see an option that says Open the Slab Flexure Report, which we can click on. Clicking this, VisualFoundation takes us to the report view, where we can see that the number 4 bars at 18 inches on center are failing for the top and bottom bars in both the X and Y directions. To fix this, let's go back to the model view and define the slab reinforcement. We'll type, for the foundation reinforcing, use number 6 bars, top and bottom, at 12 inches on center each way. Use 3 inches of bottom cover and 2 inches of top cover. Looking in the inspector, we see that the reinforcement and the cover was set as specified. We also see that now the slab flexure is just barely failing. The program suggests that a small adjustment to the rebar, such as tightening the bar spacing or increasing the bar size, will likely allow flexure to pass. Clicking on Open the Slab Flexure Report once again, we can see that the bottom bars in the X direction are the bars that are failing. As a result, let's go back to the model in Load View and make one more reinforcing change. We'll say, change the bottom bars in the X direction to 9 inches on center instead of 12 inches. At this point, the footing design is passing, but the pier still has an issue. We'll ask, it looks like everything is passing except the pier. Why is it failing? IES Intelligence shows that the pier is failing due to 2 issues found in the design table. First, it has insufficient longitudinal steel, as ACI 318 requires a minimum steel area of 2.25 square inches for the 15-inch by 15-inch pier, but only 0.8 square inches is provided with the 4 number 4 bars. The minimum 1% steel ratio is not met. Second, the transverse spacing is too large. ACI 318 limits the tie spacing to 8 inches maximum, but the current number 4 ties are spaced at 12 inches. The combined axial and bending check and shear check are both passing, so only the reinforcement detailing needs to be corrected. Increasing the longitudinal bars and reducing the tie spacing should resolve both failures. It then asks, would you like to update the pier reinforcement? To which we'll say, yes, update the pier reinforcement. Now we see that the program says, after updating the longitudinal reinforcement and reducing the tie spacing, the pier is passing. Now everything in the project status looks good, and our design is complete. One thing to note is that project status shows that punching shear was checked. It may be helpful to see more details about how that check is being performed, so let's ask, I see that punching shear was checked. Can you summarize how that is done, and where can I find more info on that check? IES Intelligence provides a summary of how VisualFoundation performs punching shear checks. It explains what is checked, how the critical section is defined, and how the reinforcement depth is determined. It also discusses groups and punching reinforcement. Finally, it shows the path to the punching shear section in the help file where we can learn more. Now that the footing, bearing, stability, slab design, and pier design are all passing, let's generate the final report. We'll say, everything appears to be passing now. Generate a report with the tables for the pier, foundation, stability, bearing, and other relevant design results so this can be documented. Switching over to the report view, we can see that a complete report has been generated summarizing the design. In the Modify tab, we can see the various tables that have been included which we can modify if needed. This is just one more powerful way we can use IES Intelligence to better understand, document, and communicate our design. This example shows the intended role of IES Intelligence. It does not replace the engineer, and it does not change the calculations being performed by VisualFoundation. Instead, it provides a faster and more natural way to control the same program. We can still model manually. We can still inspect the model visually. We can still review the design tables and reports. But now, when we want to create, modify, investigate, or document a foundation, we can simply describe what we want in plain English. That is the goal of IES Intelligence. the same trusted VisualFoundation workflow with a more powerful and natural way to interact with it. Thanks for watching and have a great day.